Good morning, students. This is Savita, Associate Professor in Mathematics. In this video, I shall discuss consistency of a system of linear homogeneous equations. This video is useful for 5th semester BSc students. Okay. Now let us consider a system of linear homogeneous equations in n unknowns. Let us begin with the m equations in n unknowns. Say x1, x2 and so on xn. So the first equation is a11 x1 plus a12 x2 plus so on plus a1n xn is equal to 0. The second equation is a21 x1 plus a22 x2 plus so on plus a2n xn is equal to 0. The third equation is a31 x1 plus a32 x2 plus a33 x3 plus so on plus a3n xn is equal to 0. Similarly, the mth equation, which is the last equation, is am1 x1 plus am2 x2 plus so on plus amn xn is equal to 0. Okay. So we have m linear equations in n unknowns. Now first we write the coefficient matrix. Let us denote the coefficient matrix by capital A, which is equal to a11, a12, so on a1n. The second row elements are a21, a22, so on a2n. And the mth row elements are am1, am2 and so on amn. We find the rank of the coefficient matrix using elementary row operations by reducing the matrix to triangular form. That is, we find the rank of the coefficient matrix by reducing it to upper triangular matrix or lower triangular matrix using elementary row operations. There are m equations in n unknowns. Suppose the rank of the coefficient matrix is equal to n, the number of unknowns or the number of variables. The equations, that is the system of equations, have only zero solution. That is x1 is equal to 0, x2 is equal to 0 and so on xn is equal to 0. If r is less than n, that is the rank of the coefficient matrix is less than the number of variables, the equations have n minus r independent solutions. What is the meaning of this? The number of linearly independent solutions of this system is n minus r implies if arbitrary values are assigned to these n minus r of the variables, the values of the remaining variables can be uniquely determined. I hope it is clear. Suppose m is less than n, m andre the number of equations. If it is less than the number of variables, then the solution is always other than the zero solution. Okay? That is, solution is not a zero solution. We have a non-trivial solution. If m is equal to n, that is the number of equations is equal to the number of variables, the necessary and sufficient condition for the solutions other than the zero solution is that the determinant of the coefficient matrix is equal to 0. So keeping this in mind, let us solve a problem. So let us understand the conditions once again. If r is equal to n, r andre rank of the coefficient matrix is equal to the number of variables, the system of equation has only a zero solution. Zero solution andre x1 is equal to x2 is equal to and so on is equal to xn is equal to 0. Onde solution sittade. If r is less than n, the equation have n minus r independent solutions. When m is equal to n, the necessary and sufficient condition is that the solution is a non-trivial solution and the determinant of the coefficient matrix is equal to 0. When m is less than n, the solution is other than the 0 solution. Okay. So keeping this points in mind, let us solve one problem. Solve the equations 4x plus 2y plus z plus 3w is equal to 0. 6x plus 3y plus 4z plus 7w is equal to 0. And the third equation is 2x plus y plus w is equal to 0. So there are three equations and four unknowns or four variables, namely x, y, z and w. So according to this, here m is less than n, isn't it? In this problem, m andre number of equations. More equations ide that is less than n. M is less than the number of unknowns. So the solution is always other than the 0 solution. Now let us find the rank of the coefficient matrix to test whether the solution is whether there are n minus r independent solutions where r is a rank of the coefficient matrix. Okay. So let us write the coefficient matrix first. Coefficient matrix is first row elements 4, 2, 1, 3. Second row elements 6, 3, 4, 7. Third row elements are 2, 1, 0, 1. Okay, there is no z here. So other value 0 ಬರ್ತದೆ ಇಲ್ಲಿ. So third row elements are 2, 1, 0, 1. And the method is reduce the coefficient matrix to upper triangular form or lower triangular form. That is, reduce the coefficient matrix to triangular form using elementary row transformations. Now here, let us reduce the coefficient matrix to triangular form, upper triangular form. Okay. Now upper triangular form andre enu? Elements below the leading diagonal 0 ಆಗಬೇಕು. So there are three elements, on the 6, ಇನ್ನೊಂದು 2, ಇನ್ನೊಂದು 1. So ಈ ಮೂರು elements ಅನ್ನು 0 ಮಾಡುವ using elementary row transformations. Okay. ಈಗ ಈ 6 ಅನ್ನು 0 ಮಾಡಬೇಕಾದ್ರೆ since first element 4 ಇರೋದ್ರಿಂದ ಇಲ್ಲಿ 6 ಆಗಬೇಕಾದ್ರೆ we multiply the first row by 3 by 2. So 4 into 3 by 2 is equal to 6. Then 6 minus 6 is equal to 0. So the first row operation is R2 minus 3 divided by 2 into R1. So we have 4 into 3 by 2 is equal to 6. 6 minus 6 is equal to 0. So this element is 0. The next element is 2. 2 into 3 by 2 is equal to 3. 3 minus 3 gives 0. So this is 0. Let us consider the third element. 1 into 3 by 2 is equal to 3 by 2. 4 minus 3 by 2 is equal to 8 minus 3 divided by 2, which is equal to 5 by 2. And the last element is 3. It is multiplied by 3 by 2. So 3 into 3 by 2 is 9 divided by 2. 7 minus 9 divided by 2 is 14 minus 9. That is equal to 5. So 5 divided by 2. Now let us consider the third row elements. Third row element 0 ಮಾಡಬೇಕು. ಈ element 0 ಮಾಡಬೇಕಾದ್ರೆ ಇಲ್ಲಿ 2 ಬೇಕು. ಇಲ್ಲಿ 2 ಬರಬೇಕಾದ್ರೆ ನಾನು half ಇಂದ multiply ಮಾಡಬೇಕು. So the next row operation is R3 minus half R1. R3 minus half R1. So we have 4 into half is equal to 2. 2 minus 2 gives 0. Consider the next element. 2 into half is equal to 1. 1 minus 1 is equal to 0. Then we have 1 into half is equal to half. 0 minus half is minus half. 3 into half is 3 by 2. 1 minus 3 by 2 is minus half. So this matrix is reduced to upper triangular matrix. Now in order to find the rank of the coefficient matrix, we find the minus of order 3 or order 2. So minor of order 3 ಸಿಗ್ತದ ನೋಡುವ. Since these elements are equal, ಇಲ್ಲಿ ಸಹ 5 by 2 ಮತ್ತೆ 5 by 2 ಇದೆ, ಇಲ್ಲಿ ಸಹ minus half ಮತ್ತೆ minus half ಇರೋದ್ರಿಂದ ಪುನಃ elementary transformations ಯೂಸ್ ಮಾಡಿ ನಾವು ಈ ಎಲಿಮೆಂಟ್ 0 ಮಾಡ್ಲಿಕ್ಕೆ ಆಗ್ತದೆ. ಈ ಎರಡು ಎಲಿಮೆಂಟ್ 0 ಮಾಡ್ಲಿಕ್ಕೆ ಆಗ್ತದೆ. ಸೊ ಇದು 0 ಆಗಬೇಕಾದ್ರೆ ಇಲ್ಲಿ half ಅಂತ ಬರಬೇಕು. half ಬರಬೇಕಾದ್ರೆ the next row operation is R3 plus 1 by 5 R2, isn't it? 1 by 5, 5 by 2 multiplied by 1 by 5 ಅಂದರೆ ನಮಗೆ half ಸಿಗ್ತದೆ. So 5 divided by 2 into half is equal to half, minus half plus half is equal to 0. Okay. So the next row operation is R3 plus 1 by 5 R2. First row elements ಮತ್ತು second row elements change ಆಗುವುದಿಲ್ಲ, they are unchanged. Third row elements are all 0. So look at this. This is a matrix of order 3 cross 4 where third row elements are all equal to 0. So minor of order 3 vanishes. Minor of order 2 ಸಿಗ್ತದೆ ನಮಗೆ, which means the rank of the coefficient matrix is equal to 2. Here R is equal to 2. Rank is equal to 2, which is less than the number of variables. There are 4 variables. 2 is less than 4. Hence, the number of independent solutions is equal to n minus r. That is 4 minus 2 is equal to 2. So, there are 2 independent solutions. How to find the solutions? Now, let us consider the system. This system is equivalent to, this is your new system. The given system is equivalent to this system. So, we have 4x plus 2y plus z plus 3w is equal to 0. From the second equation, we have 0 into x plus 0 into y plus 5 by 2 into z plus 5 by 2 into w is equal to 0, which gives z plus w is equal to 0. In other words, z is equal to minus w. So if we substitute z is equal to minus w here, we get 4x plus 2y minus w plus 3w is equal to 0. In other words, 4x plus 2y plus 2w is equal to 0, or 2x plus y plus w is equal to 0, or x is equal to minus half into y plus w. Okay. So we have two equations in 4 variables. Therefore, we get z equal to minus w and x is equal to minus half into y plus w. Now, let us choose w is equal to k1. If w is equal to k1, then z is equal to minus k1. Correct? Okay. Now, let us find y. Look at this equation. So, 2k2 plus y plus k1 is equal to 0. From this equation, we get 2k2 plus y plus k1 is equal to 0, or y is equal to minus 2k2 minus k1. Hence, the solution is x is equal to k2, y is equal to minus 2k2 minus k1, z is equal to minus k1 and w is equal to k1. Now, ಈಗ ಇಲ್ಲಿ x is equal to k2 ಮತ್ತೆ w is equal to k1 ಅಂತಲೇ ತಗೊಳ್ಬೇಕಾಗಿ ಏನಿಲ್ಲ. ನೀವು z is equal to k1, w is equal to z is equal to k1 ಮತ್ತೆ y is equal to k2 ಅಂತ ಸಹ ತಗೊಳ್ಬಹುದು. Okay. So since there are only 2 independent variables, we have x equal to k2, y equal to minus 2k2 minus k1 ಮತ್ತೆ z equal to minus k1 and w is equal to k1. So ಯಾವುದು ವ್ಯಾಲ್ಯೂ ಬೇಕಿದ್ರೂ ತಗೊಳ್ಬಹುದು. Okay. So this is the method of solving a system of linear homogeneous equations. Okay. I hope it is clear. Now, reference book is Dr. B.S. Grewal, Numerical Methods in Engineering and Science with Programs in C and C++. I shall stop here. Thank you.